Okay, so you're standing outside. The sky is dark. The wind is picking up. And suddenly, the ground starts rotating. A column of air is actively trying to obliterate everything in its path. That's a tornado. And here's the weird part. There are way more types than you think. Like, the atmosphere is so creative about destroying things that it's invented multiple different ways to spin and kill. Some of them shouldn't exist.
Nope.
Some of them exist on fire. Some of them exist inside volcanoes. And we're going to talk about all of them. Because apparently, understanding how the air can murder you is just something humans need to know now. Let's start simple. You know what a regular tornado is? Rotating column, goes down. Everything screams. That's a cyclonic tornado, born inside a supercell thunderstorm. The storm has this rotating updraft called a mesocyclone. And when that rotation tightens and dips down and actually touches the ground, well, you've got a problem. These are the classic ones, the ones in the movies, counterclockwise in the northern hemisphere. They can be tiny, they can be the size of a city, but they follow the basic rule. Rotating air plus ground contact equals destruction. Got it? Moving on. But here's where things get insane. Because tornadoes don't actually need a supercell. They don't even need to follow that formula. The atmosphere is way more creative than that. Waterspouts. These are just tornadoes that decided to be dramatic about it. They form over water, ocean, lake, whatever. The way it works is actually kind of simple. You've got warm water, you've got cold air sitting on top of it. The water heats that air. That air wants to rise. When it rises and there's wind shear, wind changing speed and direction with height, boom, it starts to rotate. You get a visible funnel made of water vapor and air spinning at maybe 40 miles per hour. Most of the time, they're completely harmless. Boats see them, boats move. Everyone's fine. But here's the problem. Waterspouts don't have to stay over water. If one moves toward land, it's now a tornado. Over buildings, over cars, over people. And suddenly that weak waterspout is now a genuine threat. Landspouts are basically the land version of waterspouts, but they don't need water at all. They form in places like the western United States or Arizona or anywhere that's hot and dry. You get a patch of warm air near the ground. That air rises. Wind shear at different altitudes makes it rotate. And before you know it, a visible vortex forms. These things are narrow, they're quick, they last like 5 minutes. But they can absolutely destroy a house, they can flip a car. The reason nobody talks about them is because they happen in the middle of nowhere and nobody sees them. By the time they're done, they're done. Then you've got Gustnadoes. And I need to be real with you. A gustnado is not actually a tornado, it just looks like one. It's more of a circulation, a little whirlwind. They form along the edge of a thunderstorm's outflow, that cold wind that rushes out before the storm hits. Along the boundary between that cold air and the warm air around it, you get these tiny little eddies. Dust devils, basically. Except they're technically classified as gustnadoes. Can they cause damage? Sure, you might lose your fence, you might lose some shingles. But compared to an actual tornado, it's nothing. The wild part is that gustnadoes are way more common than real tornadoes. Way more. So, statistically, the next time you see a dust swirl and think it's a tornado, it probably is a gustnado. You're probably fine. Now let's talk about the ones that break the actual rules of reality. Anticyclonic tornadoes. Okay? So, regular tornadoes in the northern hemisphere spin counterclockwise. That's how we identify them. That's their whole thing. Anticyclonic tornadoes spin clockwise. Literally the opposite direction. What? Why would the atmosphere do this? Most of them form on the outer edges of supercells, not in the main rotating column. They're weaker than regular tornadoes. But here's the absolutely terrifying part. Storm spotters are trained to watch for counterclockwise rotation. Radar operators are trained to look for counterclockwise rotation. So a clockwise tornado can form and everyone can just miss it. You're watching the giant counterclockwise tornado. A clockwise one is spinning up 50 feet away. And nobody realizes it until suddenly there's damage from a direction nobody was expecting. It's like the atmosphere decided to gaslight meteorologists. Okay? Now we're getting to the ones that genuinely should not exist. Twin tornadoes. A single storm producing two violent tornadoes at the same time. This is so rare that when it happens, meteorologists lose their minds. The Pilger, Nebraska event in June 2014 is the gold standard case. Two tornadoes, both EF4 strength. One with winds of 190 miles per hour, the second at 170. They touch down near each other. They moved in parallel. They weren't orbiting each other. They weren't feeding each other. They were just both existing simultaneously. For the people on the ground, this is a nightmare scenario. You've got two violent rotating columns, both moving toward you. Where do you even run? Your car can't outrun one tornado, let alone two. For meteorologists afterward, damage surveys become impossible. How much destruction did Tornado A cause? How much did Tornado B cause? Where does one stop and the other start? You literally can't tell anymore. It's chaos. Satellite tornadoes are related but different. Smaller vortices that form around a larger tornado. They're like little moons orbiting a tornado planet. Much weaker, much shorter-lived, maybe a few minutes. But dangerous for exactly one reason. Everyone's attention is on the giant tornado. Nobody's watching for the secondary circulation forming nearby. So you get struck from an unexpected direction. Classic misdirection by the atmosphere. Pyro-tornadoes. This is where the atmosphere stops being a weather system and just becomes pure fury. During a massive wildfire, fire heats air to extreme temperatures. That air rises violently. Normally it just disperses upward, no big deal. But sometimes, when there's extreme wind shear, when the terrain channels winds in specific directions, when the fire is hot enough, that rising air starts to rotate. The rotation tightens, the winds accelerate, and you get a vortex made entirely of fire and smoke and ash. The 2018 Carr Fire in California produced a pyro-tornado, wind speeds of 143 miles per hour. That's EF3 strength. An EF3 powered by fire instead of a thunderstorm. Uprooting trees, destroying buildings, lofting burning debris hundreds of feet into the air. And the absolutely terrifying part? These are getting more common. As wildfires get hotter and bigger, pyro-tornadoes are becoming a legitimate threat. The atmosphere learned a new way to destroy things. Snow tornadoes, winter tornadoes, cold season funnel clouds. These form when very cold air moves over warm water, usually the Great Lakes or coastal areas. That temperature contrast creates instability. Rising air starts to rotate. A funnel forms, made of snow crystals and ice. They're usually weak, but in 2013, a winter tornado near Shelburne, Ontario hit with 90 miles per hour winds. EF1 strength. Destroyed a farm silo, damaged buildings, proving that even when everything is frozen and snow-covered, the atmosphere can still organize rotation. Volcanic tornadoes. Okay, this is where things get genuinely alien. When a volcano erupts, the eruption column shoots superheated gas and ash skyward at tremendous speed. When that column hits the surrounding atmosphere moving at different speeds, rotation can develop. Ash swirls, debris spirals, a vortex forms, made entirely of volcanic material. The 2018 Kilauea eruption produced these, columns of ash and fire rotating around the eruption plume. The internet called them lava tornadoes, because humans are creative when they're terrified. High-altitude tornadoes. Most tornadoes happen in flat terrain, but mountains exist. Thinner air, rugged terrain, complex wind patterns. On July 7, 2004, a hiker in Sequoia National Park saw something impossible. A tornado at Rockwell Pass. Elevation approximately 12,000 feet. The highest elevation tornado ever confirmed in the United States. The funnel was faint because the air was so thin that moisture couldn't condense properly. But the rotation was real. Debris was flying. This tornado proved that even in thin air with limited moisture and complex terrain, the atmosphere can organize, even in mountains, even where you'd never expect it. Wedge tornadoes. These are the monsters, the ones that break every assumption about how large a tornado can be. The 2013 El Reno tornado in Oklahoma stretched nearly 3 miles wide. 3 miles! You couldn't drive away from it fast enough. Your car would be in the circulation. From a distance, these don't even look like funnel clouds. They look like moving walls, like a dark curtain descending from space. The winds don't stay consistent. One moment it's EF4, the next it's EF2, then EF4 again. Violently. The debris load is insane. They pull in soil and vegetation and houses and vehicles, and everything gets lifted hundreds of feet into the air and dropped somewhere else. For anyone in the path, survival is basically luck. And good shelter. But mostly luck. Here's the thing that actually scares meteorologists. Tornadoes are flexible. They're not locked into one category. The atmosphere didn't decide, okay, these are the types, and only these types exist forever. Instead, it's constantly inventing new ways to rotate and destroy. Twin tornadoes shouldn't exist but do. Tornadoes inside fires shouldn't exist but do. Tornadoes inside volcanoes shouldn't exist but do. Every time meteorologists think they understand the rules, the atmosphere changes them. And the next tornado you hear about might be something we've never seen before. Something that doesn't fit any of these categories, because the atmosphere is infinitely creative about trying to kill us. That's all the insane tornado types. So now you know that the sky can kill you in like 12 different ways instead of just one. Subscribe, because clearly you need to understand how the weather is plotting against you. And click the next video to learn about tornado ratings, because apparently we needed to quantify the suffering.